Imagine you are driving on this road and you see this crack, and now you have to make a 5-mile detour to avoid this crack. If you're driving in the Midwest of the US, the crack is due to clay swelling because the Midwest has a lot of clay deposits in the sublayer of the soil. Clay swelling happens due to the sheet-like structure of clay. Clays have space in between the sheets, and when it rains, water gets into the structure, swells the sublayer, and breaks the road. You'd be surprised to know that clay swelling causes more damage than earthquake, flood, and tornadoes combined in the US. Since clay is a natural soil, clay swelling has been around for a very long time. The traditional approach to solve this problem is the addition of lime or cement with clay. When lime or cement is added with clay, they form a gel-like structure around the material, which provides clay strength and closes the gap. This is a very empirical solution, and we don't have any quantitative understanding of this. The quantitative understanding is important because the gel-like structure that clay forms once lime or cement is added with clay, it provides support only for a certain period of time. After that time is over, clay will break again and the road will break again. The current approach that we have is when we see breakage in the road due to clay swelling, we add lime or cement and then we forget about it. And then when we see breaks happening again, we add lime or cement to the structure again. This is why we keep having those economic losses. Our knowledge to this situation is very similar to 18th century doctors when they had to rely on the external symptoms shown by their patients to make a diagnosis. Now they have state-of-the-art medical equipment so they can perform CT scan and MRI on the patient to make proper diagnosis. Similarly, we can use state-of-the-art molecular tools to look inside the chemistry of the clay mixed with lime and cement so that we can make a quantitative understanding of this whole system. This is exactly the goal of my research. I'm using state-of-the-art molecular tools, looking inside the clay structure when lime or cement is added with clay. I'm looking into the chemicals they form and which provides clay strength, and I'm collecting data for 2 years of the experiments, and I'm using state-of-the-art molecular tools, and the eventual goal is to make it a quantitative model because clay reacts very slowly and the reaction process takes as much as 10 years to complete. So my goal is to collect data for 2 years and make a kinetic and thermodynamic model so that we can predict the behavior up to 10 years and apply them to real soils that we can prevent economic losses as well as those unexpected detours.